This video is going to demonstrate all the things that we need to do in order to solve what's called a linear programming problem. And a linear programming problem is a problem in which we are going to try to maximize or minimize something. We don't have a word problem associated with this one, so we're just going to go through the mechanics of solving. And so make sure you have this sheet in front of you, and please follow along as I go through things. If you notice, we have 4 constraints that we need to graph. X plus y is less than or equal to 6, 2x plus y is less than or equal to 10, and then we have 2 constraints, x is greater than or equal to 0 and y is greater than or equal to 0. The nice thing about those 2 constraints is those are super easy to graph. Remember, we have 4 quadrants. This is quadrant 1, this would be quadrant 2, quadrant 3 is down here, and quadrant 4 is in this lower right-hand corner. If our x values are positive, that means that we're going to be over here. And if our y values are positive, that means we're going to be up here. And so I can graph these first 2 constraints super easily just by drawing my graph on the first quadrant. So since my graph is basically a first quadrant graph, I have already taken care of graphing those first 2. Now that we're back to a clean slate here, let's go ahead and graph our first constraint. So x plus y less than or equal to 6. I'm going to plot this by making an xy table, and I want to plot the intercepts. So I'm going to let x equals 0 once, and I'm going to let y equals 0 once. If x equals 0, I would have y equals 6. Remember, we're just going to kind of pretend that it's an equation. We're going to worry about the inequality stuff later. And then if I let y equals 0, cover up the y, and you'd have x and a 6. We might as well make the table for the other linear inequality, this one right here. So let's make an xy table for this one. I'm going to let x equals 0 once, I'm going to let y equals 0 once. If x is equal to 0, imagine that the 2x goes away, and I'm going to be left with y equals 10. So 0, 10 is my y-intercept. And if I plug in 0 for y, the y is going to be gone, and we're going to be left with 2x equals 10, and so x would be equal to 5. Now let's go ahead and graph these. For the point 0, 6 and 6, 0, let's just kind of estimate where they're going to be. So I'm going to say this looks like a good 0, 6, and a good idea is to label this right away. So I'm going to label 0, 6 right away. And then let's label 6, 0, and I have to go about the same amount of space to the right as I went up. So maybe something like this. And I'm going to label it right away, 6, 0. Now I have to decide what kind of line to draw in. Now's when I look at the inequality symbol, and since it has the equal to, I'm going to connect these with a solid line. The reason I only drew it like that is because remember my other 2 constraints, x is greater than or equal to 0 and y is greater than or equal to 0, tells me that I'm in the first quadrant. So I'm only really interested in the first quadrant. Let's graph the second one. 0, 10 would be higher than 0, 6, so maybe something about like this. 5, 0, going to be close to 6, 0. Label it right away. I have to decide what kind of line to draw in. I'm again going to draw in a solid line because it had less than or equal to. And it's going to turn out in this case that I'm going to shade below both of those lines. Technically, I can look at the symbol only if stuff is in slope-intercept form, and those 2 expressions are not in slope-intercept form, but it's going to turn out that if I would put them in slope-intercept form, my inequality symbol would still be less than or equal to, and so this is going to be my shaded region. And what I'm going to be interested in are what are called the corner points. And so we're going to have to calculate the corner points. Now some of these I can already figure out. Corner points are on the boundary of the shaded region. So out of 0, 6 and 0, 10, 0, 6 is a corner point. Out of 5, 0 and 6, 0, 5, 0 is a corner point because it's on the boundary of the shaded region. Hopefully you can see another corner point that I could label right away. And that would be this corner point right here, which is going to be the coordinate 0, 0. So that's also going to be a corner point. I have one other corner point that I need to calculate, and that's going to be this corner point right here. I'll bet you I can estimate what it is, but I want to find it exactly. And that's what we're going to do on the next part. Now, what we're going to have to do to figure out the intersection point is to solve the system of equations. I'm not going to pay attention to the inequality symbol anymore. I only needed it to know what kind of line to draw and where to shade. I've already done both of those. And so the two lines that intersected at the point that I don't know yet is this one, x plus y, and instead of writing less than or equal to 6, I'm just going to write equals 6. Again, I've already done stuff with the inequality symbol, so I don't care about it anymore. The other line is 2x plus y equals 10. Again, I'm not caring about the inequality symbol anymore. So I need to solve this system of equations. I could choose to use the elimination method or the substitution method, and it doesn't matter. I'm guessing most people would pick the elimination method, so I have to decide, do I want to eliminate the x's or do I want to eliminate the y's? If I wanted to eliminate the x's, I would have to change the top equation to make it have a negative 2x. If I want to cancel out the y's, I'd have to make one of those equations have a negative y instead of a positive y. I think that's going to be the easier thing to do. So I am going to, just for the sake of example, multiply my bottom equation by negative 1. So now let's write down what our new equations are. Our top equation stays the same, x plus y equals 6. Our bottom equation now turns into negative 2x minus y equals negative 10. Let's add these together. I would have negative x equals negative 4. And then if I divide both sides by negative 1, I'm going to end up with x equals positive 4. Halfway done. Now I got to plug x equals 4 back into one of those two equations. I think I'm going to choose to plug it into that top equation because that seems pretty easy. So I would have 4 plus y equals 6, which means that y would be 2. So my missing corner point is the coordinate 4, 2. So let's list our 4 corner points. 0, 6 was one of them, and 0, 0 was one of them, and 4, 2 I just calculated, and 5, 0. The purpose of a linear programming problem is to try to maximize or minimize some quantity. And in this problem, just for the sake of example, because there's no word problem associated with this, we want to maximize profit. And for some reason, profit is equal to 4 times the x coordinate plus the y coordinate. So we're going to test each one of those 4 corner points. So I want you to write down 0, 6, and we're going to write them on the left-hand side here. 0, 0, 4, 2, and 5, 0. And what I need to do for each one of these is I have to test these corner points. Remember, my first coordinate is x, and my second coordinate is y. So I'm going to plug in the first case, 0 for x and 6 for y. So I would have 4 times 0 plus 6, which gives me an answer of 6. For 0, 0, I'm going to have 4 times 0 plus 0, which is 0. For 4, 2, I'm going to have 4 times 4 plus 2, and that's going to give me 18. And then 5, 0, I'm going to have 4 times 5 plus y, which is 0, equals 20. So then what I need to do is figure out which one of these points gives me a maximum profit, and all I got to do is look for the biggest number. And this point right here gives me the maximum profit. It doesn't matter that it wasn't the point that I solved for. It could have been any of those 4. And it just so happened that 5, 0 is the one that's going to give me the maximum profit.